Ooh, welcome to Dark Dragon Does Math. Here's my awesome lightsaber. Just wanted to remind you that it existed. We're doing the Chapter 9 study guide. Basically, we're just I'm going to break this up into about 3 videos, maybe 2, and we're going to try to, hopefully I can explain all this. So it's pretty easy, but this is all review. So the first question, give the coordinates of A, B, C, D in A and the quadrant in which they lie. So A is right there. That's at -4, -3, and remember the quadrants are quadrant 1 starting there, quadrant 2, quadrant 3, quadrant 4, and so A is in quadrant 3. Point B is right here. That's 0 in the x direction, -6 in the y, and that's not in a quadrant. Technically, that's just the y-axis. We could say C is in quadrant 3. It's +2, -4. D is 6, 3, and that is in quadrant 1. And then E is -2, +3. And that is in quadrant 2. Use the coordinates plane from number 1 to plot the following points. So I'm just going to plot these F, G, and H. F is at 3, 4. So 3, 4. There's F. And make sure on your test that you label those. G is at -3, -5. It's going to go right there. And then H is at 4, 0. Alright. 3. Point G and R are reflections of each other about the y-axis. So G and there's an R reflected across the y-axis. So however the distance to here needs to be the same distance over here. Well, this is -3, so there's 3 from here to here, so there needs to be 3 from here to here. So R goes there, and I want to give the coordinates of the point R. So R's coordinates are 3, -5. Another way to think about that is, remember G was -3, 5, and when you reflect about the y-axis, you change the x-coordinate from a negative to a positive, or vice versa. And if you were to reflect across the x-axis, that's supposed to be a negative, then the 5 would become, well, the y-coordinate would become positive instead of negative. Alright, here I'm going to draw XY axis, and I'm going to plot these points and then tell me what the figure is. Pretty simple. Okay, and so we got A is -3, -1. So -1, 2, 3, -1. There's A. B is at 3, -1. So there's B. C is 3, 1, 2, 3. Wait, it's 3, 5. So 4, 5. 1, 2, 3 up to 5. And then D is -1, 2, 3 up to 5 as well. So this shape I'm making is either a square or a rectangle. Technically, all squares are types of rectangles, but so we just need to decide if the side lengths are the same. So this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Since the side lengths are the exact same, this is a square. And then this question has to do with this. The graph from number 4. So this is the graph. What's the line segment AB and line segment CD? So we want to find AB and CD. So AB and CD. Remember, it's a square, so they're all the same. And like this was 6, so they are both equal to 6, and you can't see that. Sorry. Okay, use the graph number 4 to find the segments. So AB and CD are equal to 6, and it's important to write units. Okay, so the segments are both 6 down and 6 across. Okay, so that's that. Yeah, and I'm going to keep going. So the diagram shows the plan of a garden. The side length of each grid is 5 feet. So So every single unit is 5, but it says that. It says -5, -10, -15. We just have to remember that when we're doing it. So use the diagram for 6 through 9. So the tomato plant is planted at point T. It's 10 feet away from the line PS. So here's PS, and we want to do 10 feet away. So remember, this is 5 feet, 10 feet. So it's somewhere on this line, and 10 feet away from SR. So SR is down here. So 10 feet away from SR is somewhere on this line, where they cross. That's where T is. So T is going to be right there. So that point is -10, -10. So the coordinates of that point, -10, -10. Plot point T on the coordinate plane and give its coordinates. There's a gate to the garden at point U, which lies on the line PQ, so it's somewhere up here. And it's 10 feet away from point P, so P, 5, 10. So it's right there. There's U. So we want to know the distance to the gate at point U in the tomato plant, so T. So what's this distance? Well, they're 5 apiece, so 5, 10, 15, 20, 25, 30. They're 30 feet away. 30 feet away. Another way you think, so 20 to 0 is 20, plus 0 to -10 is 10. 20 plus 10. There's a sign hanging on the fence line, SR. So somewhere on this line is a sign. It's hanging 10 feet away from point S. So here's S. So it's right there, and 15 feet away from point R. So 1, 2, 3. So here's my sign. My sign is right there. And don't get confused, because some of my students were saying that, oh, it's not one point. And I know it's not one point. It's a sign. It's got some length to it, and we want to find that length. So how long is it from here to here? So it's 5 feet, 10 feet. It's a 15-foot sign. 15 feet. The sign is 15 feet long. And calculate the area of the garden. So we need to find the side lengths again. So the area of a garden. So this right here, there's 1, 2, 3, 4, 5, 6, 7, 8. And each one is 5. So there's 8 of 5. So that means that this whole length is 40. And it's a square, but we can still say, okay, so 5, 10, 15, 20, 25, 30, 35, 40. Yeah, so it's a 40 by 40 garden. So the area is going to be 40 times 40. So 2 zeros, 4 times 4 is 16. So it's 1,600 feet squared. Oh boy. Let's go ahead and finish. All in one video. Water is being drained from a fish tank. The water level y centimeters at time x minutes is given by y is equal to 60 minus 5x. Complete the table, graph the relationship between x and y, and we get to the good part. Use 1 unit on the horizontal axis to represent 1. So let's start at 0, 1, 2, 3. I won't write them. Just so you know, the bell is about to ring. I'm going to finish, but it's going to happen. It's in 2 units to represent 10 centimeters. So every 2 is 10. So 10, 20. And technically, if each one is 10, so 5 is right there, and so forth. But okay, now I also want titles. So this right here, left and right, that use axis to represent 1 minute. So this is minutes. And then this represents centimeters. And if you wanted to get technical, this is time in x minutes. And this is water level in y centimeters. Okay, and then every good graph has a title. So let's say our title is tank water level. Alright, so now I'm going to plot the points I know. I don't know all the points, so I'm going to plot the ones I know. I know there's a point at 250, So that's up here, and there's a point at 820. So 820 is right there. And so to find the rest of my points, what I'm going to do is I'm going to draw a line between these points. Let's get a straight edge. So all right, so I've connected my points, and so here's the graph. That's the graph, and I can figure out how to fill in this just by looking at this now. So I know there's a point at 4. Well, 4 is right there at 40, and once you notice that every 2 it's kind of going down by 10. So this is probably going to be 30 down by 10, 20 down by 10, 10. Okay, so we got the graph and we got our table set up. What is the water level at 3 minutes? Okay, let me use a different color so this stands out. So at 3 minutes. At 3 minutes, we are right there. So that is 45 centimeters. How many minutes will it take for the water level to be 25 centimeters? So here's 25. So we go down. That would be 7 minutes. How long will it take to drain all the water from the tank? That's when it's down to 0. The water level is at 0 at 12. We can see that from our graph. If we didn't get all the way down there, say you stopped at 10 because 10 stopped here, just think about it. Okay, so it's dropping 10 minutes every 2 minutes. So 12, 12, drop 10, 0. Oh, cool. And what's the average drainage rate in the fish tank? We already said every 2 minutes it drains 10 centimeters. So I want this to be 1 minute. So go from here to here, you divide by 2. 10 over 2 is the same thing as 5 over 1. So 5 centimeters per minute. And that's the review. Hope that was helpful. Have a good day. Math!